Next, we're going to continue about the centroid for regular shape. Centroid is geometric center of the centroid coincides with the center of mass and center of gravity. So as you can see here, some example of the regular shape, which is circular, rectangular, triangular, quarter circle, and semicircle. As you can see here, the centroid for circle the middle. Also, for the rectangular here, you can see the C or centroid at the middle as well. However, for the triangle and for the triangular, from the base, the center line for the centroid is 1/3 of the H value, which is H is height of that triangular. For the quarter circle, the centroid lay at 4/3 r divided by pi on x-axis, while for y-axis also 4/3 r divided by pi. So here is the centroid for quarter circle. And for the semicircle, from the base of this semicircle, the centroid line lay at 4/3 r divided by pi. Here is another example for cylinder. So as you can see here, centroid for cylinder on this is circle. Therefore, at the middle is lines of that axis. When you're going to find where is that centroid will be, we know our height of our cylinder is H. Therefore, because it's symmetry, H divided by 2. So here is centroid for this cylinder. Also, bear in mind, the centroid may not located on the body. Now, how about the centroid of composite body? Composite body is a body made of a combination of complete shape such as triangle, circle, or others. As you can see here, for this one, it combination of rectangular, then circle, then triangle to make this body. And for the second body, as you can see here, the first one is triangle, the second one is the hollow rectangular, and the third one is the bigger rectangular for this body. For next eye section, first one is this rectangular, second one is this stand rectangular, and the third one this rectangular. Also here mention to you how we going to determine the location of G for the composite body. For the application for us as civil engineer, as you can see here, here is a steel structure for the building. For this beam made from I-beam section, while in here you can see the T-beam shape. This commonly used for construction for civil engineering. Therefore, we need to identify where is the centroid or center of gravity for this shape. For example, you can see here for T shape, once we calculated the centroid, and we assume here is the line of our centroid. Therefore, here also lay neutral axis for this T-shaped beam. So for this neutral axis, important for you to know later on for next subject where you're going to study about stress distribution. Here is another application. As you can see here, this is the box girder. Therefore, it is important for us as engineer to find where is the centroid for this box girder. Also here you can see different shapes of the structure, then combined with another structure here. So that's mean it's become more complicated in the real life. Here is another example on bird nest stadium in China. This main structure made from steel. As you can see here, the shapes getting more complicated. Also you can find in YouTube how they built this bird nest. Next, let's do example 6.3. For this composite block, we need to find the centroid of this body. So for this one, we need to identify where is the centroid from the axis X, Y, and Z. So the dotted line mean the lines behind that. So here lay coordinate 0, 0, 0. For this composite body, we can divide into 3 segments. For the first segment is the shaded triangle. Therefore, for this shaded triangle, we need to determine volume for that. So we name as volume 1. So look on this shape, this triangle. We know the height on z-axis is 1.8 and length on x is 1.5. Therefore, we can identify area for this triangle. Therefore, half time by the base times the height 1.8, that's area. Then the thickness for that is 0.5. So time 0.5. Then we get volume V1 is 0.675 meter cube. Then we need to identify the location of centroid for segment 1. So on X bar, we're going to look on X axis. Therefore, on X axis, here is X axis. The coordinate must take from 0, 0 coordinate. Therefore, for triangle, it is the centroid lay at 1/3 from here. That means 1/3 of length of 1.5. Then we need to plus another 0.5. So this is 0.5. So here is 0.5. That means the total of X bar is 1 meter. Next, we need to identify our Y bar. That means on Y axis. On the Y axis, we look from here. Therefore, 0.5 divided by 2, we get the center line on Y bar is 0.25 meter. Then, we need to find what is centroid line on Z bar. So this is Z axis. The height of that is 1.8. So we need to know this is distance. That means 1/3 from the bottom. So 1/3 divide 1.8. So we get 0.6. So we identify location for this segment 1. Next, we're going to do for segment 2, which is this rectangular shape. Then, volume for V2 is this length 2.5 times by height of this 1.8 and thickness of this is 0.5. So we get volume for V2 is 2.25 meter cube. Then we need to identify our X bar. Our X bar on X axis is 0.5 divided by 2. So here is 0.5 divided by 2, we get 0.25 meter. Next, we're going to find y bar. That means on y-axis, this is y-axis. Length of this is 2.5. So 0.5 plus 2, 2.5, divide by 2, and y bar is 1.25 meter. Then for z, on z-axis, the height of this is 1.8. The center for that one is 1.8 divided by 2, we get 0.9 meter. We done for segment 2. Now we're going to do for segment 3. So volume for segment 3, V3, is this triangle. So area for triangle, half time by 1.8, time by the base 1.5, and thickness for this is 0.5. So we have volume for this segment is 0.675 meter cube. Then we need to calculate our x bar. So on x-axis, thickness for this is 0.5. That means slice into 2, 0.5 divided by 2, we get 0.25 meter. Then y bar, 1/3 of 1.5 here, 1/3, 1.5 plus 2.5, this length 2.5, so we get y bar is 3 meter. Then we need to find our z bar. So our z bar on z-axis, the height of this rectangular is 1.8. So from the base is here, 1/3 of 1.8, we get 0.6 meter. That means we calculated all those values. Previously, we calculated our volume, our x bar, our y bar, and z bar for each segment. Then we sum up total volume. So we get 3.6. Then we need to fill value for v time x bar, v time y bar, and v time z bar. Be careful on those units. For v is meter cube because it's volume. For x bar, y bar, and z bar is meter. That means value for v time x bar is meter power of 4. Then we need to fill this value. Then we need to sum up value for Vx bar, Vy bar, and Vz bar. Then we need to find the centroid for this volume. So on x bar is summation of Vx bar divided by summation of V, and for y bar is summation of Vy bar divide summation of V, and for z bar is summation of Vz bar divide summation of V. By doing so, we get value for x bar, y bar, and z bar. That means the centroid for this body is 0.309, 1.39, 0.78 meter. So we write this answer in coordinate form.